Before we jump into ASP.NET MVC, I want to take a step back and look at source control. Now, if you're not familiar with the term, source control is essentially the practice of using one of the many available source control products to track the changes of your code over time. Now, it is going to be it's pretty much established these days that source control is a best practice for really anything. And it's been this way for quite a few many years. Because what it allows you to do, even with your local, private, personal projects, it allows you to track the change of your software over time. It allows you to experiment with things and either merge those experiments into your main code or discard them entirely, depending on how well the experiment went.
Now, this sounds like something that is a really, really good idea, but maybe lots of people, when they're working on their own projects, don't use.
That's true, and it's unfortunate. And I've also done it myself, where I don't put everything under source control, even though I should. but but it's something I really want to instill in this video series, because this video series, like you saw earlier, is really all about best practices and how to put stuff together in the most optimal way without cutting any corners. And one of the corners that is cut often is source control. Now, source control does a lot of things, depending on what product you use. And there are a variety of products available. You'll most commonly probably see SVN floating around. It's a fairly older one that's used and still is very popular and still is very useful. And more recently, especially with the advent of GitHub.com, we've seen a lot of Git. And Git is the one that I'm going to be using. We're not going to actually go over every single feature of Git. In fact, we're not even going to scratch the surface of what Git can do. Git is an amazing product that was created actually specifically to handle the largest open source project in the world, Linux. So what Git allows us to do is it allows us to create our own little local repositories and track changes to our files over time and see those changes whenever we want. So that's the product we're going to be using. I'm not going to get into an SVN versus Git versus Mercurial versus Perforce debate here. And we're not going to be talking about branching or merging or remotes or anything like that. Instead, we're going to focus on exactly what it is we need from Git in order to accomplish what I would consider to be one of the most important software development practices that you can develop. So now, Git does not come with a UI. Git is a command line tool. In fact, since Git was obviously created for Linux, it only recently, and I'm saying recently in terms of software development, so as a couple years ago, it only recently became very stable on Windows. And when that happened, a lot of people started creating products that wrap over Git, that allow us to use a user interface to work with the Git executable. So what we're going to be using is we're going to be using a combination of the command line tools as well as a free Git user interface called SourceTree. Now, SourceTree is made by Atlassian, which is one of my favorite companies, and it allows you to, well, use Git and Mercurial. Mercurial is a similar distributed source control system as Git, but we're not going to be using it. We're going to be using Git.
The key word there to me is free.
Oh yeah. SourceTree is free. You can go ahead and just download it and grab it, and it's pretty good. I like it. There are alternatives though. There are a couple open source Git GUIs like Git GUI, Git extensions. There's also a commercial one called SmartGit, which I'm also a big fan of. But we're going to be looking at SourceTree. Now, because we're also going to be using the command line tools, I would recommend going ahead and grabbing Git for Windows. So go to mysgit.github.io and you'll want to go to downloads and you can just click on the latest installer, run that through, and you will have Git installed as a command line utility on your system. Now again, like I said, we're going to be using SourceTree in addition to the command line utility. So I believe the SourceTree installer will pull down a version of Git if you don't have it installed. I haven't installed SourceTree on a computer that didn't already have the command line utilities. So either way, download this one first and then download this, or just download this. You'll get the products that you need.
Sounds like fun.
Alrighty. So what I'm going to do is I'm going to open up a folder. And I'm going to create a Git repository. Then I'm going to open it up in SourceTree, and we're going to take a look at the basics of committing files and reviewing our changes and reverting back to old changes. So the first thing I'm going to do is create another folder. I'm going to call it Simple Blog. Open it up. Then I'm going to open up a PowerShell window. You would also be able to do this with the command line window. And since I have Git configured to be present in my path, I can just type in Git and hit enter, and I see that Git is available, and it gives me a list of all the commands I can use.
That's nifty.
Yeah. So now that we have Git, we verified that we can access it. Let's issue the init command to Git. So I'm going to say git init. Hit enter. Now it'll say initialized empty Git repository at my folder. Now what's interesting is if we look right here, we now have a hidden .git folder. It's important to understand that every single file in the simple blog folder is technically a part of the repository. The repository is the individual project that we just created with Git, so you'll have a repository per project. And when we're looking at this file system in this folder, we're actually looking at the Git repository, but there's also this .git. What do you think is stored in here, Stephen?
Stuff and things.
This is the internal Git stuff that stores our objects and our refs and our hooks and all that fun stuff that we're not going to get into. Basically, you can think of it like this. Most of the files that are going to be located in this folder are part of the repository. And this .git folder will contain the history of every single file since the Git repository was created. So if you delete the .git folder, well, you just lost all your history. So do not delete the .git folder.
So is that kind of like the tools that make the tools you're creating work? If that makes sense.
I don't know, but it might make sense to someone. So I guess I'll agree with it.
So no then.
But yeah, this is where your history is stored, and we'll see an example of that in a second here. Because what I'm going to do is I'm going to open up SourceTree. I'm just going to launch it, and we now have SourceTree. I'm going to go ahead and copy the path here so I don't have to navigate all through my hard drive, which is a very scary place actually.
I've seen it. It is. It terrifies me.
So I'm going to go ahead and actually, hold on. I can just drag and drop repositories. I forgot about that feature. So I'm going to back up to web. I'm going to click and drag simple blog, and I'm going to plop it down inside of SourceTree. So now we've seen an example of me initializing a Git repository with the tools, with the command line tools. We've also seen me import that into the GUI tools. It's important to understand, however, that the GUI tools are really just a wrapper over this. Everything that we do inside of the GUI can be done by executing the git command, followed by any particular set of arguments. Okay, so now that we've done that, we can open our repository. So I'm just going to double click on it, and we get this. And this looks a little scary, but let me go ahead and break it down real fast. We have our simple blog repository open in this tab. We have our pending changes. We have our working copy changes. And then we have our changes our diffs right here. Whenever I say diff, I mean difference. A diff is the difference between two files, so you can see how that file changed. Let's go ahead and see an example of that. I'm going to go into my simple blog folder, not inside of my .git folder, just my simple blog folder, which is a sibling to .git, or a child, or a parent, however those relationships work. And I'm going to say new text file, and I'm going to say hello world. And then inside of the text file, I'm going to say this is a test. I'm going to close this text file to make sure it's saved on the disk. I'm going to move this out of the way. Then I'm going to jump back into SourceTree, and I'm going to see something came up. Inside of our working copy changes, we now have a file called helloworld.txt. It's important to understand that this helloworld.txt is not actually stored in Git yet. It is considered to be a change. We have changed the repository. Since the repository was empty, by adding something to an empty repository, we have changed it, which means we need to actually wait, or not wait, but go into SourceTree and tell it to track this change. The reason that you have to do it this way, the reason it's not automatic, is let's say that I added a bunch of files, like whoa and hey. We want to logically group this change, the change of adding 3 files. We want to logically group them into a single unit. That single unit is called a commit. A commit is essentially a list of changes, whether you added a file, modified a file, or removed a file. So that's why, when we go back into SourceTree, we haven't actually committed anything to the repository. It's just telling us that we have made changes.
So basically it doesn't do that automatically because it may not do it the way you want it done when it's all said and done.
Exactly. Very typically what you would do is you would implement a feature or a logical part of a feature in a commit, and then you would group up all of those changes and submit them as a single unit. You wouldn't want it to automatically do this or track the changes every time something changed, because
Otherwise you'd have stuff all over the place.
yeah, it would just be really bad. So we see we have all these files say untracked file, untracked file, untracked file. That means an untracked file is a file that's not in Git yet. So I can go ahead and I can stage these. So staging them, so I can come up here and click stage, and then I can click stage again. Then I can click stage one more time. Notice how they're moving from the working copy changes up to the stage changes.
Mm-hmm.
So I can go ahead and hit that again. So now, do you think they're in Git yet, Stephen?
I do not think they are yet.
They
because
aren't.
I haven't seen a commit thing.
Nope. Right now, all I've done is I've said, okay, you've told me what has changed on my file system, and I told you that I want these 3 changes, which happen to be all of them, to be represented in my next commit. So now I've staged them. Let's actually show an example of that. I'm going to unstage my woe.txt. So now my woe.txt isn't going to be included in this commit. However, the hello world and hey are. So now what I want to do is I want to commit. How do I commit? Well, there's a nice little button up here.
Oh, I like buttons.
Yes. Well, it's a GUI, so it's a button. I could show you how to do it in the command line, but it might freak someone out.
Yeah, it would me.
Okay, so I'm just going to hit this button, commit, and now I get the ability to type in a message. Now, it's very important to put descriptive messages into your commits. You want to describe not what exactly was done. Well, I guess you could say you want to describe what was done, but not how it was done. You want to say, I implemented feature X, or I fixed bug Y. You don't want to say, I added this file, this file, this file, I changed this file into this, and that file into that, I deleted, because that's already handled for you by Git. Git knows the files that you changed and modified, but you have to put in a commit message that explains why these changes have happened.
So it's more of a declaration of what you did rather than a description.
Right.
Okay.
So they typically need to be short, and they need to be informative. So I'm just going to call this one, however, initial commit. The reason I'm doing that is that's typically that's a common practice, which essentially means this is the first bit of code that I'm putting into Git. You can assume that, I mean, there's really nothing to say about it, unless you have something to say about it, which you would put it here. But typically I say initial commit. I usually do that immediately after creating a project from a template in Visual Studio. And then from every subsequent commit, I talk about what was changed. So anyway, now that I've done that, I can go ahead and hit commit. So what's happened is you see our files have disappeared from save changes and working copy changes. You see our woe is still in working copy changes, which means it hasn't been committed yet. It's not in Git. But if we go over here, we see that our files still exist as they did before. The interesting difference is now Git actually owns, or in this Git folder, there is a copy of these 2 files that I committed. We can actually kind of see that by going to our objects. I know we said we weren't going into objects, but one of these object files contains our text files that we just imported, because it's now stored in Git. So now that we've done that, how do we deal with changes? Well, I'm going to open up I'm not going to open up woe.txt because that's not tracked by Git. Instead, I'm going to open up hello world.txt. I'm going to say this is a change. And then I'm going to close Notepad to make sure that it's saved. Come back over here into SmartGit, and we'll see that now there's a new working copy change. But instead of an untracked file, it's now a modified file because it already is being tracked. And look over here. We now have a diff that's describing exactly what happened to change the file.
And immediately above that, it tells you that it's modified and how much modification happened.
Yep.
Cool.
So I'm going to stage it, then I'm going to commit, and I'm going to say added changes, which I literally just did because I just said this is a change. Obviously, added changes is a completely useless git commit message, which I am guilty of having written quite a few times. Because obviously, if you're committing something, you've changed something, but still.
But in this case, it's perfect.
Yeah. Anyway, so now I can commit, and we now have that change committed into our repository. So this is our awesome ability to track changes on our project. So we have a bunch of different features that we can use. A lot of these we don't really want to worry about. We don't want to worry about things like checking out branching, merging, tagging, submodules, or remotes. But instead, let's go ahead and take a look at our log. So I want to go ahead and see what's changed with the repository. So I'm going to go up to View, Log View. And I can see we have two commits. We have one which is my initial commit, and another one that's add changes. And I can see that, indeed the changes are down here in my diff. Now there's a lot of fun stuff that we can do. We can actually check out these changes. So if I wanted to go back in time, I could actually right-click on added changes, hit checkout, and I've gone back in time. And if I
So it seems to me then that so long as you're always doing this as a best practice, even if it's something you're working on 2 years down the road, you can always come back and see every little thing that was ever done.
Right. I also messed up a little bit. I meant to check out the initial commit. So it'll say, checking out the commit will create a detached head. Don't worry about that. It's not something you would typically do. I'm just trying to prove a point.
Okay.
So now I go into Hello World and you see my changed file is gone. So now I'm going to go back and reset my head up to added changes, and we're back to normal with a reattached head. Anyway.
Strangely, that actually made sense to me.
Now, typically you would generally, what I've done is I've rarely ever rolled back an entire repository, but I do like to cherry pick out files. So I can right click on this and I can view its information or view its file. So yeah, I mean, I guess that's really about it. We've just been looking at how to view our diffs, and that's all we really need at this point. We just need to be able to commit and view. I highly encourage people to go out and learn more about Git. It's an amazing product that really allows you to, well, it just makes coding a whole lot easier because you no longer have to worry about losing your changes. You no longer have to worry about experimenting with features and all that fun stuff because we can do branching and merging. I'm so tempted to do a video on branching and merging right now, but unfortunately that's out of scope.
Yeah, let's not do that. Let's stay to task.
Right. There's one more thing of Git that we need to know, and that is our git ignore file. Git ignore, which funny enough, I don't think I'll be allowed to create it. I know in Windows 7, nope, I can't create a file called .git ignore. The git ignore file, which I'm going to create by just creating a txt of it and then opening up. Actually, I wonder if I can just remove the extension now. Nope. I'm going to open up a PowerShell and I'm going to move gitignore.txt to .gitignore. I know that's really gross what I just did, but Windows simply does not let me create a file called gitignore with Windows Explorer. But anyway. The git ignore file is a file that describes to Git how to ignore certain things. Now, you'll see that you'll very commonly you won't select individual files to stage. Instead, you would I'm pretty sure there's a button called commit all that commits all of their changes. We'll typically be doing this. But then what if we have files that we don't want to commit, such as our binaries, our compiled files and other things that isn't appropriate to have in a repository? Well, we need a way to tell Git to ignore a file or a directory, and that's where the git ignore file comes in. So you see that it's right inside of here of my root of my repository, git ignore. I can open it up in Notepad and edit it as a text file. Watch what happens when I type in woe.txt. Save this file, Control S, come back to SmartGit, SourceTree. And let's try to go ahead and commit all. Now, if we go back and commit all, notice how our woe.txt disappeared. It's no longer going to automatically commit woe.txt because it's ignored. It'll still show down here in our working copy changes, but that's fine.
All right, so basically it's a way to create a good control line.
Right, it allows us just to prevent SourceTree or Git itself from adding files into the repository that we don't want to be in the repository.
Cool.
We'll be using a git ignore with our project to make sure that we don't get it bloated with things like compiled files and debug symbols.
Ah, okay, awesome.
Okay, so that's about it. Just to recap, source control lets us, well, walk through the changes of our project. We're going to be committing at the end of every single video here to get a nice commit log and to be able to watch our progress. Like I said, it's a best practice that you should do on public or private projects, professional or personal projects. It's very easy. It's free. SourceTree is free. I highly encourage people to go through the motions of doing this for this set of videos just to help them to start understanding the benefits and power of using Git.
And it seems like something, even if they just follow along, it's going to start making sense pretty fast.
Right. If you just follow along with the motions of doing basic commits, that's the first step to learning Git. Don't try to get into advanced stuff like branching and merging just yet, but just get comfortable with committing, staging, and ignoring files. Then move on to the more advanced features that will really seriously blow your mind.
Cool. I hear another VTM in the process.
Yeah, I'm thinking about it. Alrighty, I think that's about it. So we're going to go ahead and now finally jump into ASP.NET MVC.
All right.